Good afternoon, class. Here's Chapter 3 Derivatives, Section 3.7, Derivatives of the Logarithmic Functions, Part 2. We want to differentiate y equals e to the power of 2x times ln x. And I'm going to put a raised dot in between, which means we are going to use the product rule, and I'm going to call it f times g, and we're going to use the product rule. F prime g plus g prime f. So f prime, any exponential, the answer is itself, times the derivative of its exponent 2 by the chain rule. This is f prime times g ln x plus g prime f. G prime is simply 1 over x times f e to the power of 2x. And we're done with calculus. We are going to take the common factor of e to the power of 2x out. This leaves us with 2 ln x. This leaves us with 1 over x. We are done. Y equals log base 3 of square root of x. As we did with the exponential, when we had the base e, we knew how to do. And when the base changed, we went to logarithmic property. So in this case, we are going to go with the change of base formula and write log x base b is ln x over ln b. Bear in mind, ln b is a number, which means I'm going to rewrite this as 1 over ln b times ln x. Please understand what this means. There is a number times ln x. This is its coefficient, its multiplier. So if I want to differentiate this one doesn't change. It's a number times the derivative of ln x, which is 1 over x, and we can rewrite it. So if I want to differentiate this, the very first thing I do, because I want to use properties of logs to make it easier to decompose it, I'm going to write square root of x as x to the power of 1/2. Otherwise, I have to take the derivative of square root of x. So now I put the 1/2 in front using number 7, the power rule. So if I want to differentiate this now, 1/2 doesn't go away. It is the coefficient. Flip this over, 1 over x. The base is not e, so you need 1 over ln b. And that makes it 1 over ln. The base is number 3. We just rewrite it as 1 over 2x ln 3. You don't want to put this after ln 3. If you do, you have to put a raised dot because it has to be separated from ln 3. F of x is log base 5 of x squared plus 1. We haven't done that yet. That ultimately uses the chain rule. So how do we differentiate log of f of x base b? Then first thing first, we flip it over. By the chain rule, we need the derivative of f of x, which makes it f prime of x. And by the change of base formula, because the base is not e, we need 1 over ln b. And we put them all together. So with that case, number one, you're going to ask yourself, can I decompose this? The answer is no. So you're going to move on. First, flip this over. So 1 over x squared plus 1. Then by the chain rule, the derivative of the expression, which is the argument of log, results in 2x. And finally, since the base is not e, 1 over ln of the base 5. So you rewrite this 2x in the numerator, this is in the denominator, and you definitely don't want to keep the parentheses after that. Okay, so you write 2x over x squared plus 1 times ln 5. Y equals ln of sine x. There's nothing to decompose, so flip this over. By the chain rule, we need the derivative of the argument, that means the derivative of sine, which is cosine x. Now, as you recall with trigonometric identities, tan x is sine x over cosine x, or 1 over cotangent x. Cotangent x is cosine x over sine x, or 1 over tan x. Secant x is 1 over cosine x, and cosecant x is 1 over sine x. So this one tells us cosine x over sine x must be cotangent x. ln of ln of 5x. Recognize this as some function, for example, g of x. So we are going to use this 1 over g of x, 1 over ln of 5x. Then g prime. Now you need to differentiate ln of 5x, and you are going to use this again. How do you differentiate this? Flip this over, 1 over 5x, and then times its derivative, 5. So we use the chain rule in conjunction with the logs, how to differentiate a log 2 times. Now, number 5 and number 5 cancel each other, and we get 1 over, we put the x in front because otherwise it's awkward, x ln of 5x. If you put the x to the right, one may think it's ln of 5x times x, or ln of 5x squared. You know what I mean? The other thing I want to mention, this can be cut into 2 pieces, ln 5 plus ln x, but it may make it a little bit sometimes difficult to see how you differentiate. So it's easier just to follow this methodology. Y equals 1/2 ln of 1 plus x over 1 minus x. To differentiate class, first and foremost, we cut this into 2 pieces using number 6, the quotient rule. So we keep the 1/2, and we write ln of the top minus ln of the bottom, meaning ln of 1 plus x minus ln of 1 minus x. What if we don't? Well, if we don't do that, 1/2 remains. To differentiate this, you first flip this over, which is not too bad, but then you have to differentiate this using the quotient rule. And normally students make a mistake with that when they go the wrong way. The easy way always is better. So I want to differentiate this. So I'm going to keep the 1/2, and I'm going to differentiate this piece first. Flip this over, 1 over 1 plus x. And by the chain rule times the derivative of the parentheses, which is just 1. Minus the same thing here. Flip this over, 1 over 1 minus x, times its derivative, which is -1. That's why it's important to write it. Over here, if you didn't write it, wouldn't make any difference, but it does make a difference here. I suggest you write both. Now, Please understand this is the extent of your calculus, and I'm going to put the asterisk next to it. You're done with calculus. Now everything else is everything that we did here is algebra, and from here is algebra 2. So this fraction is negative and negative plus 1 over 1 minus x. So this entire fraction is this. Their common denominator, or LCD, is 1 plus x times 1 minus x. So if we keep the 1/2, the common denominator is 1 plus x times 1 minus x. So this one would be 1 times 1 minus x. This one would be 1 times 1 plus x. And now if we simplify the numerator, this becomes 1 minus x plus 1 plus x. X and minus x cancel each other. You get 2. 2 and 1/2 cancel each other. You get 1. These two, their product is 1 minus x squared. So the final answer is 1 over 1 minus x squared.